All right, good day everyone. Welcome to this exciting episode of our YouTube tutorials, and we're going to be looking at the concept of organic chemistry, and I'm going to look at alkanes in this video. So, I'm going to look at alkanes in this video, and I'm going to quickly look at the alkanes. So, I'll begin with the alkanes. Our continuation of the organic chemistry series that we already began. Okay, the alkanes quickly. We already said I'll quickly introduce the alkanes and what we mean now. Um, Organic chemistry is actually a big aspect of chemistry, and we have different families of compounds. But particularly today, I'll look at the alkanes. The alkanes are organic compounds actually with no functional group, so they have no functionality. So they do not have a functional group. Yes, they have no functional. There's no distinguishing feature or but as regards functional group or functionality to the alkanes. And alkanes are hydrocarbons. They contain carbon and hydrogen only with the CnH2n plus 2 general molecular formula. Okay. Now for this, for alkanes, N should be at least 1 and above. That's N should be greater than or equal to 1. Okay. For alkanes, actually, the first member of the alkanes is C1H4. So that is methane, which is the first member. We have a lot to talk about this guy. Second member is C2H5. If you're still struggling with naming compounds, check the previous video on nomenclature of organic compounds, and we'll trash all this in the cover now. So that's for the nomenclature. That's for the general formula of alkanes. The alkanes basically in their structure, their three-dimensional structure, they have what we call a tetrahedral geometry. Okay, they normally have a tetrahedral geometry, right? So each carbon is arranged in a or rather, the hydrogen or the atom surrounding the carbon atom in an alkane is tetrahedral in geometry. So this is what we mean by tetrahedral geometry. Let me just adjust it. Okay, yeah. So we'll say something like this. See, yeah. So each carbon has a tetrahedral geometry. So in an alkane, each carbon has a tetrahedral geometry for the alkanes. Each carbon has a tetrahedral geometry, and um, the alkanes are also called paraffins. Okay, you might want to ask why they are called paraffins. The organic compound called paraffins. Okay, this paraffin term is usually for the aliphatic alkanes. When we say a compound is aliphatic, it means that the compound is not aromatic. So in organic chemistry, when I say a compound is aliphatic, it means the compound is not aromatic, and there are rules for aromaticity. Okay, so aliphatic alkanes that are either straight chain or branch chain are called paraffins. So straight chains. So when I start drawing structures, you see them. So straight chains or branch chains alkanes are called paraffins. Straight chain or branch chain alkanes are called paraffins. So I call them paraffins. Yes, paraffins. Now, paraffins came from a Greek word, came from Greek words meaning parum and affins. Parum means partial. Parum means partial. Affins means affinity. So alkanes, straight chain or branching alkanes have partial affinity. And it should be noted, now when we say straight chain or branching alkanes, we refer to something like this, okay? I mean something like this, straight chain. So a straight chain alkane should be, let me not draw skeletal structure, let me just draw straight structure, normal structure. The straight chain alkane should be something like this, CH3, so CH2, CH. So when the aliphatic chain is like this is referred to as a paraffins. But when the aliphatic chain is like this, when it is cyclic, when the aliphatic chain is cyclic, yes, when the aliphatic chain is cyclic, they are referred to as naphthalene. So Cyclic chains alkanes or cyclochains alkanes are called naphthenes. Naphthenes. So cyclochain alkanes are called naphthenes. Straight chain or branch chain alkanes are called paraffins. Okay. Um, that's okay. That's for that. Now, alkanes also have a lot of characteristics. A lot of characteristics. Now, remember each carbon is tetrahedral in geometry. That means the way the atoms are coordinated around it is in a tetrahedral manner. Okay, and there's usually what we call a bond angle. Now, the bond angle for the alkanes, whether cyclic chain or straight chain, in as much as you have single bonds and you're an hydrocarbon, no functional group, the bond angle of such alkane is usually 109.5 degrees. Some other texts will say 109 degrees, 28 radian. Okay, that's for the bond angle of the alkanes. Um, that's your bond angles. Now, each carbon atom in an alkane molecule is sp3 hybridized. So each carbon atom in an alkane molecule is sp3 hybridized. That means you have 4 hybridized orbitals, and one of them is s and 3 of them is p. So sp3 hybridized, each carbon is sp3 hybridized. There's no news that they are saturated. That's why they have partial affinity. They are saturated, and we prefer substitution reaction instead of addition reaction. So we will prefer substitution reaction instead of addition reaction. Now, alkanes are the simplest organic compounds. Alkanes are the simplest organic compound, and if an alkane loses an hydrogen, you get an organic group referred to as an alkyl group. So when alkane loses hydrogen, we have an organic group referred to as an alkyl group. Yes, so that's for alkyl group. So we'll quickly look at the classes of alkyl group. All right, so um, let me quickly explain something for you guys. Now, if I have an alkane like let's say I have an alkane like this, let's say let's say this is the second member CH3 single bonded CH3. So this is usually a condensed structural formula. So let me open it up. So open this guy up should have something like CH. So I should have H up. What I have side? I have H. I have H, H, and H. So I should have something like that. Okay. Open that guy up. I have something like that. So I have something like that. So this is alkane, um, the alkane structural formula being opened up. Okay. The same thing. Now, if this alkane should loses an if the any carbon or this alkane at all, any of the carbon loses an hydrogen, becomes something like this. So let me draw that. So I should have something like H, C, H. I have H. I have H. I have H. I have H. Okay, lose an hydrogen. So yeah, I should have CH3 to CH2. Yes. So this one is an alkyl group. This one is an alkyl group. This is an alkyl group. This is the alkane molecule. So when we say alkane, when they lose hydrogen, they form alkyl. It should be noted that alkyl groups, their general formula is CnH2n plus 1, like that. So as simple as that. So that's for alkyl group. Now, I'll quickly classify every carbon atom and every hydrogen and alkane because it will be very relatively used in their reactivity. How they react. We should use the type of hydrogen. So I'll tell you this is a secondary hydrogen and cannot be oxidized. This alkyl have a primary hydrogen and so on and so forth. So please, the hydrogen atom in each carbon can be classified in an alkane. Also, the carbon atom will also be classified. So the hydrogen atoms can be classified, the carbon can be classified. So let me just quickly show them. Now, first, I'll start with the alkane molecules, and I should have a C, H, H, I have H, I have C, I have C, C, H, H. So I have H, H, H. So let's make it more interesting. And I have let's say I have CH3. So let's make it more interesting. CH3, and I have CH3. Quickly. Now, please watch. Does everybody watch? And now, if you observe very well, this carbon has three hydrogen, or we say the carbon has three hydrogen and has one carbon atom attached to it. So when a carbon has one carbon atom attached to it, or it has three hydrogens, or some cases four hydrogens, so I'll just say three or four hydrogens, that carbon is referred to as a primary carbon. So therefore, the hydrogens are called primary hydrogens. So this is a primary hydrogen atom, this is a primary hydrogen atom, this is a primary hydrogen atom. Now watch. When a carbon is attached to two carbon, or the carbon is attached to one hydrogen. So, okay, pardon, this one is three carbon. Okay, let me make it more. Okay, let's open it up. Let's open it up. So you understand what I'm trying to talk about. So let's say yes H, yes H, let's say yes C, let's say yes CH3, yes CH3, yes CH3. Beautiful. So now this is 1 degree alkyne, or a primary. When I say primary, I mean 1 degree. So 1 degree hydrogen, 1 degree hydrogen, 1 degree hydrogen, 1 degree carbon. Now come here. So this is tertiary. If this was what I can quickly relate. Now come here. Now if you see this carbon is bonded to two carbon. This carbon, asterisk at the middle, is bonded to two carbon. So this carbon is referred to as a secondary carbon. Another way to quickly know secondary carbon, the carbon normally has two hydrogen. So on an alkane, when a carbon has two hydrogen and it is bonded to two carbon, it is secondary. Remember, for primary, the carbon was bonded to one carbon. Yes, one carbon, and it has three hydrogen. Now it is bonded to two carbon and it has two hydrogen. So a secondary carbon. So the hydrogens become a secondary hydrogen. They become sec hydrogen. We don't call them secondary hydrogen, we call them sec hydrogen. Sec hydrogen. Okay. So for this carbon is attached to three different carbon. Check. One, two, three. This carbon is attached to three different carbon. One, two, three. And it has just one nitrogen attached to it. So when you are in an alkane or an alkyl molecule, when you have when you alkane or alkyl, and you have, I'm going to also classify alkyl, please follow. Alkane or alkyl, and you have one hydrogen, alkane or alkyl, and you have one hydrogen attached to a carbon, and that carbon has three other carbon. Such carbon is referred to as a tertiary carbon, and the hydrogen is a tertiary hydrogen. Yes. Now, there are usually no 4 degree hydrogen. So there's not like a 4 degree hydrogen. But let me just quickly explain 4 degree carbon. What is a 4 degree carbon? Now, 4 degree carbon is simple. So a 4 degree carbon is when a carbon is attached to four different carbon. So first of all, if you understand the rule of tetravalency, you know that a carbon atom in organic chemistry should take four atoms at either side. So if you check, carbon take one, carbon take two, carbon take three, carbon take four. So it has four carbon, no hydrogen attached to it. So this carbon is a 4 degree carbon. I said there are no 4 degree hydrogen. Now 4 degree stands for quaternary, quaternary carbon, quaternary carbon. So this is a quaternary carbon, this is a secondary carbon, this is a tertiary carbon, this is a primary carbon. So you can get an organic compound and they will ask you how many 1 degree, 2 degrees, and 3 degree carbons are present in the compounds above. Simple technique. And the most important route you should always follow is the amount of carbon that they are bonded to. The amount of carbon that the carbon in question is bonded to. Don't forget that. What do I mean? For instance, now this carbon is bonded to how many carbon? One, simple, 1 degree. This carbon is bonded to two carbon, simple, 2 degree. This carbon is bonded to three carbon, one. This carbon is bonded to one, two, three, 3 degree. This carbon So 4 carbon, 1, 2, 3, 4, 4 degree. As simple as that. Now it can also work for alkyl group. For alkyl group, we can also go on and work for alkyl groups. Go on and on for alkyl groups. Okay, for alkyl groups, I can have an alkyl group like this. Let's say this is C. Please watch CH3 CH, so CH2. So this is an alkyl group. Now the carbon in the alkyl group that has lost the hydrogen, the carbon in the alkyl group that is deficient, that has lost the hydrogen, that normally may carry this hyphen to nobody, is the guy that determines whether the alkyl group is primary, secondary, or tertiary. Yes. Now I'll use 3 carbon alkyl group. So this is CH3, CH2, CH2. So normally it's supposed to be CH3, CH2, CH3. That should be propane. Now this is propane, my exact point. So this is propane. So this is propyl losing an hydrogen. Now the carbon that has lost the hydrogen, or the carbon that is making it an alkyl group, is bonded to 1 carbon. So this alkyl group is a primary alkyl group. This is a primary alkyl group. Now let's take another case. Now this same alkyl group, see propyl. This propyl. So this propyl. So no, there's nothing like a primary propyl. We'll just say it's a propyl. So this is a propyl group. So this group is propyl. Okay. Now we can have propyl like this now. So let's see CH3. We have C. Now we have CH. We have CH3. Yes. Yes. So because the guy bearing the alkyl substituent now, because this is the carbon making it an alkyl group. So this is the propane. This is the carbon that has lost hydrogen. Now, so the middle carbon. So when the middle carbon lose hydrogen, because this middle carbon that loses hydrogen, if you check, this middle carbon is bonded to two. This middle carbon is bonded to two alkyl groups. Bonded to two alkyl groups. Because this middle carbon is bonded to two alkyl groups, we will say that this middle carbon is a secondary carbon. So because the guy bearing the alkyl substituent is a secondary carbon, it becomes a sec alkyl group. So this is sec propyl. Sec propyl. So we might literally not have a tet propyl for propane. So or for propyl. Usually a tet propyl cannot occur. Why? Why can a tet propyl not occur? This carbon cannot be bonded to 3 different carbons because the compound has 3 carbons, or the alkyl group has 3 carbons. So let's go to butyl. So butyl will be more appropriate. So butyl should have okay, let's use it. So butyl should have butyl should have CH3, CH2, CH2, CH3. Yes, 1, 2, 3, 4. That should be a butyl. Now, please just watch. Butyl, the guy losing the hydrogen is the first guy. So, sorry, that was butane I drew earlier. So, this is butane. Don't forget, when butane loses an hydrogen, it becomes butane. This is butane. So, when butane loses an hydrogen, it becomes butyl. So butane, when it loses an hydrogen, it becomes butyl. So butane loses an hydrogen, becomes butyl. So this is butyl now. The guy that loses the hydrogen, or the guy making it a butyl group. This is the guy making the butyl group because it's the one that loses the hydrogen. The guy that loses the hydrogen contains how many carbon? This guy that loses the hydrogen contains it is bonded to how many carbon? This guy loses the hydrogen. It is bonded to how many carbon? It is bonded to 1 carbon. So this guy is a normal butyl. If there's any word like that, yes, a normal butyl or a primary butyl. Now, when the guy that makes it a butyl group, is a secondary carbon. So now this is also butyl. Now this is also butyl. But this time, the guy making it a butyl group is a secondary carbon. Why is it a secondary carbon? Because the carbon is bonded to 2 different. Yes, the carbon bonded to 2 different. This carbon in question is bonded to 2 different carbon. So this makes it a sec butyl. So we can also have tet butyl. So how do tet butyl resemble? Now let me show you tet butyl. Now for tet butyl, we have a butyl group. Now CH3, CH3, CH3. Now this is also butyl. If you can't, now there are 9 hydrogens here. 3 plus 3, 6 plus 2, 8 plus 1, 9. There are also 9 hydrogen with 3, 3, 3. But this is the guy making it an alkyl group now. So this butyl group is not a self butyl, neither is it a neither is it is not a self butyl, neither is it a normal butyl. So this type of butyl, because the carbon making it a butyl group is bonded to 3 carbons, so this is referred to as a tet butyl. So in your trivial nomenclature, when you see a compound called tet butyl chloride, that's what we mean. When we see a compound called tet pentyl chloride, you know what we mean. Tet butyl chloride. So these are the way we can classify alkyl groups. Simply, very simple ways we can classify alkyl groups. So I will leave them. So you have to look at them properly. Look at them properly. They look dicey. Look quite a little bit dicey. So with these few points of this video, I'll wrap the video here, because I'm going to treat alkanes in possibly 4 or 3 videos. I'm going to treat alkanes in 3 videos. This will be alkanes 1. Yeah, alkane, the first video of alkanes. Now, this first video has to do with the introduction, the basic properties of alkanes, and so on and so forth. So on the second video, I'll have to do the preparations and the introduction of the first member, the preparations of alkanes, and the chemical properties. But before I leave, I will quickly like to talk about the physical properties of alkanes. Yes, so I'd like to talk about the physical properties of alkanes. So the physical properties of alkanes and how they. All right. So the physical properties of alkanes include first one. I'll talk about boiling point very fast. Okay, I'll talk about boiling point. So I'll talk about boiling point. I'll talk about their melting point, which works with their boiling point also. Okay, and I'll talk about solubility. I'll talk about solubility. I'll talk about polarity. I'll talk about polarity. I'll talk about I'll talk about physical properties, solubility, polarity. Talk about density. Yes, I'll talk about density. So I'll quickly talk about this one, then wrap up this video till alkanes 2. Okay, for boiling point, the boiling point of alkanes are usually very dicey. Yeah, they are very tricky. But we'll break them down in this video. In this video. Now, for boiling point of alkanes, for boiling point and melting point, I work together very fast. Now, the boiling point of alkanes increases as the carbon atom increases. So what I mean is that the boiling point of methane, for instance, thereabouts is around minus 164 degrees Celsius. Now, it increases as you progress, and you progress and progress. Then we get to pentane, C5H12. The boiling point of pentane is around 36 degrees Celsius. So we have 36 degrees Celsius, we have minus 164. You see, as carbon atom increases, boiling point is going to increase. So I think from ethane is around minus 96 degrees Celsius or so. Yeah. So the boiling point increases as carbon atom increases. Also with melting point. So the melting point does the same. Now, but I'll quickly talk about something. Now, for instance, you have an alkane. This one is very dicey. You have an alkane like this. CH3, CH2, CH3, okay, CH2, CH3. So I'll work with this pentane. Okay, CH2, 1, 2, 3, 4, and we have CH3. Now this is pentane, a normal pentane. Now normal pentane has a boiling point of around 36 degrees Celsius. Now, there's something that affects boiling point that is so very strange, and that is known as branching. So this is a straight chain alkane. If this alkane is peradventure it is branched by isomerization process, I can have an alkane such as this, CH3CH, and I have CH3, I have CH2, CH3. So this is 2-methyl pentane, 2-methyl pentane, which we popularly call isopentane. Isopentane, on the other hand, now have a boiling point of 28 degrees Celsius. Yes, So this is the use ratio. So branching reduces melting point. Now, if you further branch this compound again and you have something like CH3, then you have CH3, you have CH3. Now, this is also a pentane derivative, but this time, if you have to name this compound, it is 2,2-dimethyl. Watch my nomenclature video. 2,2-dimethyl propane. 2,2-dimethyl propane, you have a lower boiling point, and even this one because it is more branched. And 2,2-dimethyl pentane, pardon me, 2,2-dimethyl propane is known as neopentane. So please take note, when an organic compound is drawn like this, it's referred to as a neo compound. So this neopentane has a boiling point of around 9.5 degrees Celsius. So branching also reduces melting point and boiling point. Now, alkanes in generally, alkanes in general are usually insoluble in water. Yeah, they're usually insoluble in water due to polarity. So they are weakly polar or they're usually non-polar. So they don't have a good solubility in water, but they dissolve in solvents such as toluene, ethers, benzene, because those solvents are also non-polar. As you know, in the rule of solubility, like for like, that's the primary rule for solubility. So polarity, alkanes are weakly polar, and because they are weakly polar, they exert a form of force, a form of weak van der Waals force that can also affect their stability. So this van der Waals force can cause strain in the molecule, and takes us to a aspect of alkanes. We talk about conformation. So we have to talk about Straggart conformation, eclipse conformation, and anti-Angorchi. So those things will be treated in the subsequent videos on conformation. So I'm going to do a video on conformation. So conformation will be different. So those ones are for the conformations of alkanes, and it is due to the big van der Waals force in their molecule, which can also affect their stability. So density, please take note. And for alkanes, as carbon atom increases, because density is directly proportional to mass, we're very used to your density. So density is really mass over volume. So density is directly proportional to mass. So the higher the molecular weight, the higher the density of the alkane. So density, boiling point, and melting point work together. Density, boiling point, melting point, they work together. So at this point in time, we call it a day for this video, and I have to stop it here because I don't want to make it longer. So just anticipate the alkanes 2 video, and we'll have to treat the the preparations, the laboratory preparations. Talk about the first member, how you can prepare alkanes, and the ones that can be common in your environment. You can prepare alkane in your house, okay? And you just need the carbide. So I'll tell you the carbide in the next video, and the reactions of alkanes. And the last video we have to do will be on conformation. So until we meet again, it's a wrap up. So I remind the analogous, make sure you subscribe after watching this video. Make sure you subscribe. Thanks for watching. So have a nice day.